watch the video later. Okay, great. Now you can see the question if you're watching the video later. To those of you in the future watching the video later, now you can see things. Factoring and solving equations of higher degree order, we're solving this equation. And just like every time we bring everything to one side, you don't have to pick the side where the highest power of x has a positive coefficient, but it's usually better to. Then there's two steps to our factoring. The first step usually is to factor out the greatest common factor. In this case, each of these pieces have an x to the third I can pull out or factor out. So I'm going to factor out an x to the third. I'm left behind with an x squared. Here I'm left behind with a 9. And I should really point out, when I'm factoring this out, I'm really thinking about the additive law of exponents, right? When I factor out x to the third, I'm really thinking, oh, x to the fifth divided by x to the third. I subtract those coefficients, and 5 minus 3 leaves me behind with a 2. What I really think about is that if I multiplied this back through, I would add those and they would add to 5. That's how I'm really actually thinking about it. And then at this point, I think you have a couple choices. Really, if we wanted to factor it as much as possible, we should keep factoring. So this part here factors as x minus 3 times x plus 3. You could also, at this point, just set each part equal to 0. You could say, I'm going to set x cubed equal to 0 and take the cube root of both sides and get x equal to 0. When you have x to a power equals 0, you're always going to get, when you have x to a positive power equal to 0, you're always going to get 0 as an answer. And then you could also, you could just jump straight here and say, oh, x squared minus 9 equals 0. You could solve this kind of the other way, not by factoring, but by saying x squared equals 9, x equals plus or minus the square root of 9. So x equals plus or minus 3. But I kind of like that. There's a good reason to factor things as much as possible. And so I kind of like doing this and say, oh yeah, I get x equal to 0, and x equal to positive 3, and x equal to negative 3. Either way you go about it, you should get the same answers. And I would encourage everyone to factor as much as you humanly can possible. Those words did not go in that order, but it still makes sense. Factor as much as humanly possible. This is a preview. So, hey, by the way, I just want to point out, I didn't do this on purpose, but it's totally here. Here is some 17C quadratic formula use that, for those of you in the 17 series, this is in your future. Not like future watching this video, like future in spring quarter, or maybe fall of next year. Fall of next year. Yeah, whatever. Fall of 2021. Yeah, that's next year. Okay, a lot of these equations are going to have some x equal to 0 solutions. For example, sure, 8x to the 5th equal to x to the 6th. And if it were me solving this, I would bring everything to the right-hand side, because that's the side with the bigger power of x where it's going to have a positive coefficient. So you can either go this way and say 8, whoops, that's all I have to do, and say 0 is equal to x to the 6th minus 8x to the 5th. But you could also bring everything to the left. You could alternatively do 8x to the 5th minus x to the 6th is equal to 0. Or you could even do it as minus x to the 6th plus 8x to the 5th equal to 0. Any of these are options, and any of them are fine. And in most of them, I'm still going to do the same thing. In this one, I'm going to factor out x to the 5th, the greatest common factor. I'm left behind with an x minus 8. And then I'm going to set each factor equal to 0, right? Right? It's the same kind of thing, like all the time. So I'm going to set x to the 5th equal to 0. And I think it's perfectly fine just to say, you get x equals 0. But if you really want to show more work, you could take the 5th root of both sides So the fifth root of x to the fifth equals the fifth root of 0. But the fifth root of x to the fifth is just x. And the fifth root of 0 is just 0. Or you could just say, if x to a power equals 0, you know how x has to be 0. There's no other choice. And then here, we're going to get x equal to the best number, x equals 8. Yeah, and that's because we're setting x minus 8 equal to 0. That's or you could work it here, right? You could, from here, you could do the same thing. You could factor out x to the fifth. You're left with 8 minus x equal to 0. One thing I will caution you about this, not that you, is that you have to be careful. Here, we're still going to get x equal to 0. But I've definitely seen people get this and say that x is equal to negative 8. So just be careful with this, right? If you've got this and you're not sure, you can always just say, well, 8 minus x equals 0. And then I personally would just add x to both sides so that 8 equals positive x. Or you could subtract 8 from both sides and say negative x equals negative 8, and then multiply both sides by negative 1 to get positive x equals positive 8. No matter which way you go, you're still going to get 0 and 8 as your answers. But just be careful, right? It can be easy to kind of lose a negative sign if we're not extra careful. Yeah. Look at a few more where so again, bigger picture is we're usually looking first to see, is there a greatest common factor? I like this red pen, but I don't like what it does to my eraser. The red and the orange pens especially just like make erasers gross. Let's look at this one. 6x to the fourth plus 3x cubed equal to 9x squared. We are trying to, so when I write an equation like this, the words I am not writing are find all the solutions to 6x to the fourth plus 3x cubed equals 9x squared. And again, the first thing I want to do is bring everything to one side, right? Always, 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 always. With some exceptions, but really always, always, always. So 6x to the fourth plus 3x cubed minus 9x squared equals 0. And then we're going to ask ourselves, what can we factor out from that? Actually, let's say, what's the biggest thing we can factor out? Someone could tell me or type it.
3x squared?
Yeah, 3x squared. So I factor out a 3x squared. So again, when I say the words factor out, you could also think of I'm dividing out a 3x squared, but I'm still writing it there, right? I'm not actually dividing by 3x squared, I'm factoring or pulling it out. If I divide by 3x squared, I'm left with a 2x squared. Here I'm left with a 1x. I don't usually write the 1, I would probably just write x usually. And here I'm left with a minus 3. And then I could either try factoring or I could use the quadratic formula. So I could set each factor equal to 0. So I'm going to set 3x squared equal to 0, and that's going to give us 0. Right? You could divide by 3 if you really wanted to, and then take the square root. But the square root of 0 is just 0. Here, although this does factor, you really don't want to think about having to factor, unless specifically the problem is telling you factor this thing because I told you to, which is never really a good reason to factor something. So I know I said before, like I would factor all the time if I could, but only really if it's easy. I don't really want to factor this because I know there's another way to solve it. I'm going to just say, well, okay, x equals negative b plus or minus the square root of b squared minus 4 times a is 2 times c is negative 3 all over 2. times 2. And then we're going to simplify this. So we're going to get x equal to -1 plus or minus. Let's see, let's just simplify this real quick. So the insides there are 1 minus 4 times 2 is 8 times -3 is -24, which 1 plus 24 is 25. So I'm going to get -1 plus or minus the square root of 25, which is 5, all over 4. And then I should simplify this. It's going to be -1 plus 5 over 4, which is 4 over 4, which is 1. And -1 minus 5 over 4, which is -6 over 4, which reduces to -3/2. So those are my 3 answers here. And that's the oh, no, just kidding. I was going to say something, it was wrong. We could have factored that. We don't need to factor it. Yeah. Also, definitely stop me if you have questions. Ah, yes. Let's solve another one. Trying to use my old eraser for the red. I guess I can use some orange too. Sure. Let's do this one. Let's solve 28x equal to 7 minus 7x squared. Which side? Left or right? Doesn't
Right.
really matter. Yeah, I mean, usually it's going to be the left. But you could go right. So 7x squared plus 28x minus 7 equals 0. And we could try factoring, but I don't think this one factors. Well, that's not true. What should we do regardless? What should we factor out first? We should factor out a 7. You could, even if you wanted to, divide both sides by 7. That would actually be perfectly okay. But I want to factor out a 7. If you're solving an equation, it's okay to divide both sides by a constant. If you're actually factoring and you're not trying to solve an equation, you can't use the 7. But setting this equation equal to 0 is the same as just setting x squared plus 4x minus 1 equals 0. Right? Because 7 can't equal 0, so it's really just this part being equal to 0. And now, I don't think this factors. I don't know a way to multiply the -1 and add it to +4. So we're going to use the quadratic formula. In fact, I want you guys to use the quadratic formula. I'll give you, I don't have a clock with a second timer. That's so dumb. I'll give you 45 seconds to use the quadratic formula. I'll time it. Smart. I can do it. I can set a timer. Maybe. Do it. Sorry, I can't set a timer apparently. There we go. Okay. Okay, it's been at least 45 seconds. This one does simplify a little bit though, just so you know. So this one, if I solve it, or if I use this quadratic formula, it's going to be -4 plus or minus the square root of 4 squared minus 4 times 1 times -1. Yeah, I think I made a mistake. No, over 2 times 1. which is going to be -4 plus or minus the square root of 16 minus plus minus. A minus times a positive times a minus is a positive. 16 plus 4, so 20, all over 2. We know the insides of that square root have a square factor. That square factor is 4. Square root of 20 is just going to be 2 square roots of 5, because square root of 20 is equal to square root of 4 times 5. I don't need you to show me all this work. If you're comfortable going straight from square root of 20 to 2 root 5, that's perfectly fine. But it's also good to know how to do it in case you're not. So this is -4 plus or minus 2 root 5 all over 2. And then each thing divides by 2, so we end up getting -2 plus or minus the square root of 5. And I do want to mention here, it's really worthwhile to factor out this 7. We could have not factored it out and used the quadratic formula just from the beginning, but it's just way worse, right? If you try and use the quadratic formula here, you're going to get -28 plus or minus the square root of 28 squared minus 4 times 7 times -7 all over 2 times 7. And not that you can't calculate that, but it's clearly like this one we could do in our heads. This one I can't do in my head. You might be able to, but I definitely can't. So, right, it's nice to factor things out because it usually makes the numbers that we're dealing with smaller than they were before. Okay. Let's talk about some factoring by grouping. So we've already had, in fact, so we'll do an example of factoring by grouping that we're already familiar with. So see if this orange pen is any good. So something like 8x squared plus 14x plus 3 equal to 0. Actually, nah, sure, why not? And I want to solve this, and this time I'm going to decide to factor to solve it. Solve by factoring. We totally could use the quadratic formula here. It might get a little bit messy because 14 squared is a little bit big, but it would certainly be doable with the quadratic formula. But we're going to factor instead. So, no, that's right. Okay, I thought I was making a mistake. So I'm looking for numbers that multiply to 24. I don't know what I'm doing here. Equal to what our numbers multiply to, and numbers that add up to 14.
And 2.
Multiply to 24 with 1 times 24. Nope, that doesn't add to 14. Or 2 times 12. Oh yeah, 2 times 12. Those numbers add to 14. So that's how, so again, I want to remind you, because I know it's been a day, but that doesn't mean that this factors as x plus 2 times x plus 12. It definitely doesn't factor that way. Because if you multiply this out, this would multiply out as x squared plus 12x plus 2x is 14x plus 24. And this and this are definitely not the same. The whole point of doing this is so that we can factor by grouping. We're going to rewrite our quadratic as 8x squared plus, it doesn't matter which one you pick first, whether it's 2 or 12. I'm going to pick 2, I don't care. Plus 2x plus 12x plus 3. A good looking 3. And then, here's the thing about factoring by grouping. You have to have an even number of terms, and you're always going to group them by pairs. So usually you're going to group them by pairs. So we have a pair of things here, a pair of things here.
Do we ever have more than 2 pairs?
You can, and actually, and I think so. The thing is, I tried to come up with a problem like that. Oh yeah, I came up with one. Yeah. We'll see in 2 examples. Yes, but generally not really. Most of the time, when you're factoring by grouping, or you're thinking you might try factoring by grouping, it's usually going to be you've got 4 things and you're going to group it into 2 groups of 2. It is possible to have 6 things and group it into 3 groups of 2, or even sometimes 2 groups of 3. Basically, if you're factoring by grouping, you have to be able to make some number of groups that are all the same size. So you can't have like 1 group of 2 things and 1 group of 3 things. That would not be okay. You can have so many groups, and each group has to have the same number of pieces. Usually it's just 4 things and you get 2 groups of 2. If you had 6 things, it would usually be 3 groups of 2, but it could be 2 groups of 3. Factor by grouping is not a method that gets used a ton, but, well, I say that, but then lots of books like give you examples where it's factoring by grouping because it's kind of easy factoring. So anyway, from here, we pull out the greatest common factor, which is 2x, and we're left with a 4x plus 1. And here's what we always hope for, what we need to happen. From this second factor, we're going to pull out whatever we can, and the leftovers have to be the same. So we're going to pull out a 3, or factor out a 3, and the remaining piece better be 4x plus 1, which it is. So I want to caution you, if these are ever not the same, you have to stop and try something else, because factoring by grouping is not going to work. That should never be the case for these problems, like when you're doing a quadratic, but for other things we will see. Sometimes factoring by grouping looks like it might work, and then it doesn't. This blue pen here is really like, one of these pens is like, kind of flashing in my eye. It's weird. Okay, anyway, factor out the 4x plus 1, and then you're left with a 2x from here, and a 3 from here. And then we set each factor equal to 0. So we're going to set 4x plus 1 equal to 0, 4x equals -1, x equals -1 divided by 4, and then set 2x plus 3 equal to 0, so that 2x equals -3, x equals -3 over 2. So those are our 2 solutions to this equation. And let's look at another example. Yeah, oh well. Okay, so yeah, let's look at this one. 4x cubed plus 12x squared minus 9x minus 27 equals 0. Is this the one I really want? Yeah, it is. Okay, so when you think you might be factoring by grouping, and really just generally, when you're writing out these equations, which are polynomials in x, right? You've got x to nice positive integer powers. You should typically be writing things in the standard way, which means you have decreasing powers of x. So you always want to start with your highest power of x, and then your next lowest, which is what we've been doing, but I feel like I should say it. Like that's the way we usually want to write things. So here, from this factor, I can factor out a 4x squared. From this pair, I should say, I can factor out 4x squared. I'm left with an x plus 3. From here, I can factor out a -9. I'm left with an x plus 3. And then I can factor out this x plus 3 because it's the same, right? And so then we're allowed to factor that out, and we're left with a 4x squared minus 9. And this thing here, so I haven't said a whole lot about these kinds of things, but when you have a difference of squares, meaning you have something squared here and something squared here, and you're subtracting them, that always factors in a particular way, right? If you have a squared minus b squared, it's always going to factor as a minus b times a plus b into conjugates. So here, this piece being squared is 2x quantity squared. this piece here is 3 quantity squared. And so this we could think of as 2x minus 3 times 2x plus 3. And so then we could set each factor equal to 0 and get x equal to negative 3. If I set 2x minus 3 equal to 0, I get 2x equal to 3. I get x equal to 3 halves. And conjugates always have opposite sign solutions. So if x equals 3 halves is a solution to this, we know that x equal to negative 3 halves is going to be a solution to that factor. Couple things to say here. A different direction we could have gone. We could have just said, I don't want to think about factoring this. I'm just going to set 4x squared minus 9 equal to 0 and solve it by isolating x squared. This is totally allowed when you don't have a middle term. So you can say 4x squared equals 9, x squared equals 9 divided by 4, x equals plus or minus the square root of 9/4, but the square root of 9 is 3 and the square root of 4 is 2, so this is plus or minus 3 halves, which is exactly what we got there. And the other thing that I really want to stress is a difference of squares always factors. A sum of squares never factors. I should really say a sum of squares never factors if we're only using real numbers. It can factor if you use imaginary numbers, but that is not the world we are living in. Okay, we're looking at so here's another factoring by grouping problem. And this one definitely has 6 pieces. And so usually if I was trying to factor this by grouping, I would default to doing it by pairs. But now you've got me wondering if we could do it by something else. And I don't think this one I don't think we could. I don't think we could group, like, I mean, you could try, I'm not actually gonna do it, but like, you could do it by a group of 3 and another group of 3. And then you could try, like here I could factor out, whoops, yes. I made up this example because it's totally unrealistic, right? These are the right powers of x. I've written it weirdly because it doesn't really factor if you don't write it like this. So this is kind of a strange factor by grouping problem because you wouldn't normally see someone write a problem like this. But it does work if we factor by grouping. Here I can totally factor out an x squared. I'm left with a 2x minus 3. Here I can totally factor out a minus 3x. And I'm left with a 2x minus 3. And here I can totally factor out a 2. And I'm left with a 2x minus 3. And then I can factor out a 2x minus 3 from each of these. And be left with an x squared minus 3x plus 2. And then this I can factor further as x minus 2 times x minus 1. So I can get x equal to 3 halves, x equal to 2, and x equal to 1. But I don't think this is particularly realistic because no one is ever going to write this like this. You're going to simplify this and write this as 2x cubed minus 9x squared plus 13x minus 6 equal to 0. And factoring something like this can be challenging, right? If you're just given anything that's higher than a degree 2 polynomial and you don't have any common factors, right? There's no greatest common factor here. So if we were given this and asked to factor it, there are methods. There's something called the rational zeros theorem, which lets you kind of guess at possible zeros, but it's not foolproof. So if I was given something like that and asked to factor it, here's what I would probably do. I would probably use Desmos. So let me show you something, because I think this is worthwhile. Desmos, where'd you go? Why are you hiding from me? Sure, let's close that up. Let me share my screen. I appreciate the laughing and crying face. Yes, I'm not a murderer. Just want to point that out again, and neither are my colleagues. Share my screen. There we go. So here's good old Desmos. What I want to say is that, so when you're looking at an equation like this, when you're finding the solutions of that equal to 0, you're really finding the x-intercepts of the graph. So if I graph this thing, y equal to 2x to the third minus 9x squared plus 13x minus 6. And I zoom out a little bit. I can see all the solutions. And in this case, they're nice. I can click on them and I'm like, oh yeah, there's 1, there's 1.5, and there's 2. Great. Which totally correspond, right? Those are exactly the solutions I found. So if I look at a different problem, let's see here. So if I look at, say, I want to solve something like 2x cubed plus 3x squared minus 14x minus 15 equal to 0. Let's say I was asked to solve this. Well, this one I can't factor. At least I can't factor with the techniques we have. I could try factoring by grouping, but it's not going to work. From this first pair, I can factor out an x squared. I'm left with a 2x plus 3. And from the second pair, I can't really factor out anything. I make a factor out a minus 1, I guess. These are not the same. Which means I can't factor by grouping. So here's what I would do if I was asked to factor this. I would look at Desmos, right? I mean, assuming we're allowed to use the tools at our disposal. I'm going to graph this thing. I know we got like 10 minutes left. Come on, share. I'm clicking share. There we go. So graphing that thing, it's looking like, what have we got here? Y equal to 2x cubed plus 3x squared minus 14x minus 15. Here's my graph. Let's zoom out a little bit. So we can see the graph there. We can definitely see that there's 3 x-intercepts. And now, sometimes they're going to be ugly, and it's not going to work so nicely. But when they're nice, you go, okay, well, great. I can see that my answers are -3, -1, 2.5. What I want you to really see from this, so I know that my solutions are, I just said them, -3, -1, and -2.5, which I was referred to right as the fraction -5/2. So knowing that, we can then factor this. If you know what the zeros are or the intercepts are, you can totally factor the polynomial. So we can say that 2x cubed plus 3x squared minus 14x minus 15 equal to 0. This would totally have to factor as, so if -3 is going to be a solution, x plus 3 has to be a factor. And if -1 is a solution, or I feel like one of them was positive, I actually wrote it down negative. Let me double check here. Oh yeah, it was positive 2.5, not negative 2.5. Okay. And then if -1 is a solution, x plus 1 has to be a factor. And if 2.5 is a solution, or 5/2 is a solution, I'm going to say x minus 5/2, but that isn't quite right. I mean, it is right, but here's the thing. If I look at this, and I look at this, they're not exactly the same. Because if I multiply this one out, x times x times x would give me just 1x cubed. And I have a 2x cubed. So I need a 2 out here to adjust for that. And what I would really do is I would multiply the 2 by that factor there and then say that it's really 2x minus 5. So if you know what the zeros are by using a tool like Desmos, you can figure out how to factor a thing. Now, I know the question here was to find the zeros, so it's like, well, you could just look at find the zeros on Desmos. But I might ask you a question in the future like, use Desmos to find the factor, to figure out how to factor something like the following. Yeah. I'm probably not going to get to the last part of it. Yeah, that's all right. So what I want to say is, so here's a question I could write on your homework that I haven't written yet. Use Desmos or some tool, whatever, to factor, not solve, just factor, the polynomial x cubed minus 2x squared minus 5x plus 6. And what I want to point out first and foremost is this does not factor by grouping. I can factor out an x squared here. I'm left with x minus 2. I can't really factor out anything here. Maybe a negative. You're left with 5x minus 6. We don't have the same leftovers. We can't factor by grouping. So I'm going to use Desmos. I'm going to pretend like I used Desmos. I did it beforehand. And on Desmos, I saw that my intercepts were x equal to 1, x equal to 3, and x equal to negative 2. Those are my x intercepts. So what that means is we can factor this as x minus 1 times x minus 3 times x minus minus 2, which is x plus 2. And that'd be it. So if you know the intercepts of the graph, or I should say, if you know the x-intercepts of the graph of an expression, like you can say this is y equals, then you know how to factor the thing, which is kind of cool. Yeah, we still got 5 minutes. We got 5 whole minutes. Take a sip of water. So let's look at another question like this. Then I will set up. And we'll talk about where we're going on Monday. So let's say I had the same question for this one. Let's say I was going to have you guys do these questions, but we have very little time, so we'll just talk about them instead. So let's say I had I want to factor the polynomial y equal to 4x cubed minus 12x squared minus 13x plus 12. And again, I will mention, doesn't factor by grouping, but we can look on Desmos. In fact, let's go ahead and look. It's good to look. It's good to practice doing things. I'm gonna share my screen one more time. Desmos again. Where'd you go, Desmos? Why am I hiding you from myself? There you are. It's just, sorry. Sometimes I'm not excellent at all the things. There we go. Share it. Do it. That's right. Come on. Graph the thing. So the thing is 4x to the third minus 12, x to the second minus 13x plus 12. So there it is. I see my 3 intercepts are, ooh, did I do the wrong? I'm like, that's not what I have on my poem. Let's see if I wrote the right thing. 4x cubed minus 12x squared minus 13x. So that means I might have made a mistake when I multiplied things out. That does happen sometimes because those numbers look gross. Good job. Well, that's a bummer. Yeah, I wonder what it's supposed to be. I guess I could do the math real quick here. Let's see here. It's supposed to be 4x cubed. It's supposed to be 6x. 4x squared. Oh my gosh. 4x squared plus 2x squared. This should be an 8x squared, I believe. Nope, I've lost it. Sorry. So anyway, so here's an example of one that wouldn't be good. Because, right, the numbers here, right, I mean, you could we usually expect our factors to be like, have nice integer solutions. So in this case, this is not a good example of a problem. And I obviously multiplied something out incorrectly when I was doing the math on my own. Sometimes that happens. That's a bummer. Yeah. Darn it. I'll make a little video of me doing this one correctly because I feel like that's worthwhile. I'll set that one aside there. All right. So I know we only have a minute left. Here's what I want to say about what we'll start doing on Monday. Darn it, oh, darn it. Red pen on the floor. That's a bummer. Anyway, here's what we're going to do next week. We're going to solve things like this. X to the fourth minus 5x squared plus 4 equals 0. What we're going to see is they're going to look like, what we're going to see is, you might like to see the screen. What we're going to see is you can either factor these like quadratics. So I can think of factoring this as like x squared minus 4 times x squared minus 1. So I'm looking for numbers that multiply to 4 and add to negative 5. Or I can do what's called a u substitution for a quadratic form and let u equal x squared, so that u squared is x squared squared, which is x to the fourth. Basically, u squared should be one of the things and u should be the other thing. And then I'm going to rewrite this as u squared minus 5u plus 4 equals 0. And then factor it as u minus 4 times u minus 1. In either case, so in this case, I get x squared equal to 4, which gives me x plus or minus 2. And here I get x squared equal to 1, which gives me x plus or minus 1. You could also factor these more, but I'm doing it this way. And here you get the same thing. Here you get u equal to 4, but u is x squared, so that becomes x squared equal to 4. And here you get u equal to 1, which becomes x squared equal to 1. So we'll talk about some different forms like this and how you solve them, but it's really